inequalities in two variables. And the question is, graph the solution set. That's y is greater than or equal to 2x plus 1. Excuse me. So when we want to graph an inequality like that, we first graph the related equation y equals 2x plus 1. Do you know how to graph that? Yeah. You could graph it on paper. The y-intercept is 1, the slope is 2, or you can graph it on your calculator. I'd like you to graph it on your calculator right now. Y equals 2x plus 1. It should look like this line. This is what we call the boundary line. Because it's, do you know what a boundary is? It's like the edge of a certain area, right? So this is where it shows the edge of the area where our solution is, and that's why it's called a solution set, not just a solution. The solution here is a whole bunch of things. We want to know where is y greater than or equal to 2x plus 1. So there's a couple of different ways we can do it. But if we graph y equals 2x plus 1, and then we choose a point somewhere on that, anywhere on that coordinate system that's not on the line, we can test it. And that's what I'm going to do here, is test a point. Anybody care what point I choose? No, I'm going to pick the origin. Anybody know why? It's easy to work with that point, right? So I'm going to take that original inequality, y is greater than or equal to 2x plus 1, and I'm going to test this point 0, 0, and I'm going to see, is that point a part of the solution or not? So I go 0 is greater than or equal to 2 times 0 plus 1, and I get 0 is greater than or equal to 1 when I simplify that. Is that a true or a false statement? False. What that means is where 0, 0 is, which is to the right of this boundary line, this is not part of the solution set. So nothing over here is part of the solution set. Over here, this is the solution set. And so we see that by shading that portion of the graph. So you can see I didn't shade over here where 0, 0 is because this came out to a false statement. We do shade all of this over here. So if you're doing this on paper, on an assignment or a test, you're literally going to take your pencil and shade in that whole area. On your calculator, you can get your calculator to do this as well. Go back into y equals and go all the way to the left on the line where you wrote in your equation. So way over there to the left of your y equals is where you're going to find those greater than or less than. For this one, can you see that? 2y plus 3x is less than x minus 3. So we're going to graph that as well. But with this, we need to isolate the y first. So we'll do that by subtracting 3x from both sides. So we get 2y is less than negative 2x minus 3, and then divide by 2. Y is less than negative x minus 3 over 2. Again, you can use your calculator to graph that, but I want to show you this. When you graph the boundary line, if you're doing this on paper, can you see the difference with that line from where you are? It's a dotted line, right? This one's a dotted line, boundary line. The boundary line in the first one was a solid boundary line. Anybody think they know the difference? Right. This one doesn't include equal to, so this is just y is less than. The other one was y is greater than or equal to. If it's equal to, then the boundary line is a solid line. If it's not equal to, then the boundary line is a dotted line. And the reason is when it's less than or equal to or greater than or equal to, the boundary line points are a part of the solution. And when it's just less than or greater than, the points that are on the boundary line are not a part of the solution. The problem here is that your calculator doesn't know the difference. So you have to know the difference. When you graph it on your calculator, there's only an option for greater than or less than. So you're going to have to remember when you're doing this on a test or an exam that about the dotted or the solid boundary line. So then you need to figure out the shading, and you can do it by testing a point, or you can do it using your calculator. When you put it in your calculator, it shades to the left of that boundary line. But you can tell on this one, especially if I really zoom in, it's still a dotted line. So what that means in terms of the solution set, if you were looking for a point that satisfies that inequality, it's any of the points in that purple region. So can somebody give me one point that satisfies that inequality? So an x value and a y value? 0, -1? Oh, 0, -100. Okay, because 0, -1 doesn't work, does it? 0, -100, so way down here somewhere. That works. Yep. How about -6, -1? Yeah, it's right here, right? What about 2, 5? No, not a solution to that inequality. What about 0, 0? No, not a solution. 5, -10?
Is it going up a 5?
Yeah.
That's 5.
Then yeah.
-10. Yes. But a point like this, let's see, if we did 5 and -6.5 is right there, right on the boundary line. Is that a part of the solution set?
No.
No. If this had been less than or equal to, then that would be a part of the solution set. Because that would be the equal to part. So the points that satisfy it to be equal are on the line. When we graph this one, it's a parabola. Y is greater than or equal to 2x squared plus 5x minus 3. So it's a solid boundary line. And when you shade, when it's quadratic, you're either going to shade the inside or the outside. So the shading looks like this for this one. Inside the parabola, solid boundary line. Y is greater than or equal to 2x squared plus 5x minus 3. Here's one last question for you to try before I give you some individual work. So we're going to start with y equals a x minus p squared plus q to write the equation of the boundary line. And so the p and q, remember that's 3 and 2, the vertex. We need to choose one other point to be x and y. You're going to use this one here. 1, 0. So this one is PQ. This one is XY. So we can fill that stuff into the equation. So we'll go 0 equals A 1 minus 3 squared plus 2. And then 1 minus 3, that's -2 squared is 4. So 4A plus 2. We're solving for A, right? That's the only thing we don't know that we need. Subtract 2, and then divide by 4, and we get A equals -1/2, right? -2/4 or -1/2. So then we can write the equation of the boundary line. It's going to be y equals -1/2 x minus 3 squared plus 2. You need to fill in A, P, and Q. But then I need the actual symbol. It's not an equal sign, right? It's greater than?
Yeah.
How did you figure that out? Because it's higher than the parabola, making it greater than. You can test it on your calculator. It's not greater than or equal to because it's a dotted line. So there's the equation.